said before, like I said last time, this is one of the problems that would cause the invention of calculus. It's something known as a tangent line problem. So, what is a tangent line? Remember from geometry. Okay, so we had, probably in geometry you had something, let's see, where we had something like this, you don't need to draw that, and you wanted to touch it at one point. You ever remember that from geometry? Yes, no, maybe. Okay, so that's a tangent line. Our goal is we want a tangent line to any graph. So if we did a parabola, we want to be able to know what is the equation of a tangent line. What are the key things to be able to get the equation of a line? What do you need? Okay, what? So we need a point. What else do we need to be able to get the equation? Slope. Slope would be very helpful. So if we had a point and slope, we could use the equation, right? Or we could say we could have a slope and y-intercept. Y equals mx plus b, and we get the equation. So that's going to be what we have. Now, I have to tell you, I want the equation of the tangent line at this point. Okay, I've got the point, so I get the equation, right? So what do we need? Slope. And that's where we come up with the reason for calculus. How do you get the slope of a line like this? Is it the same everywhere? If I was doing a tangent line there, it would probably look, let's see, something like, let's see, that's more that way. Probably something along the lines like that would be your tangent line. But if I did the same thing over here, I get a tangent line like that. Right? So our goal is we want to figure out a way to get the slope. Does everybody know the idea of where we're going, what our goal is?
Trying to get the slope of the
Yeah.
tangent line.
And that's the challenge. So here's what we're looking at. We've got a line. Yeah, I've got 2 points in the line. If we have 2 points, can you get the slope? How? Slope-intercept form or slope formula. N equals y2 minus y1 over x2 minus x1, right? Now, are these going to be the slopes of the tangent line at this point? So I use these two. What if I moved it a little closer? So if I keep moving it closer and closer, it's getting closer and closer. It's the actual thing, right? And I could move it all the way until they were on top of each other, and I can have my tangent line. So this is the process we're going to do. What does this sound a lot like that we've been doing recently? Limit. We want to let this part go to 0. If we go to 0, then we're going to have our slope. So then the question is, how do we do that? So let's see. So this, I want you to write down this part. So draw, we've got a parabola. We're just going to throw it on here somewhere on a graph. We'll call this x. So what would the coordinates of this point be if this is the function x? What would the coordinates be? Well, I've got x, so I know what x is going to be there. How would I get what y is? So if I told you I wanted to value the function at x, what do? Yeah, I plug in x. So what that means is we're going to have f of x here. if this is the function f, all I do to get the y coordinates is I plug in whatever value I have right here. Right? Everybody follow that? So this is like if we had a graph here, so this is f of x equals 3x squared plus 5. And I wanted 2. 2 comma, what do I do with that 2? Plug it into my equation. So 2 squared would be 4 times 3, 12, plus 5, 18? 17, okay. 4 times 3 is 12, plus 5, 17. So, but I can also write it as f of 2. Because I'm plugging 2 into the equation. F of 2 happens to be 17 in this case, but in this case, we're going very general. So everybody following that now? Does that make sense, what we did? Okay. So I'm going to erase this. We're going to need a bit more space over here. Now, I'm going to choose another point over here. And let this distance be h. So I'm going to go up to my line, which would be somewhere up here. What would the coordinates at this point be? What? Okay, h plus x, and I'm just put x plus h, is my x coordinate, right? Because that's what I plugged in, that's what's down here. What is my y coordinate going to be? Yeah, f of x plus h. Everybody with me on that? Where these came from? Because this is an important thing. If you're not sure, raise your hand. I can explain where these came from, why we're doing these. Okay, now we're going to do something you did back in Algebra 1, but in a much more advanced form. We want the slope of the line between these. So n equals, what's the formula? Okay, what? Oh, y2 minus y1 over x2 minus x1. Everybody has that memorized, right? Or you could say rise over run, or we could say delta y over delta x. All of these work. So we're going to apply that to these two coordinates now. So what is y2? So yeah, f of x plus h minus, what's y1? F of x divided by, what's x2? X plus h minus x1. X. And we can simplify this. M equals f of x plus h minus f of x all over h. So are we with me on this? Because now is where we're going to start taking that into account. We want to move these 2 points together. What does that mean about this function? What are we going to do with this function? So how are we moving together?
Decrease h.
Yeah, we're going to decrease h. You're going to understand that? If we make h smaller and smaller and smaller and smaller, we are going to get these 2 points closer and closer together. So this is going to be the key definition. Yes?
When you say move them together, do you mean just moving h towards x's or moving them towards each other at the same time?
Well, we're reducing h. So basically we're taking this point and moving it along the closer to this point.
So we're trying to get it to that point?
Yes. So if we want the slope at this point, or at that, yeah. So we're doing an estimate first by doing these two, and then by moving this closer and closer together, we get the slope at that point. So this is the important thing. Our definition of slope, and this is a more general one than what you learned. So remember in Algebra 1, maybe 3 algebra, you learned y2 minus y1 over x2 minus x1. This is even more general, that can be used in more cases. M, so I'm going to put slope. So this is your new slope formula. The limit as h goes to 0 of f of x plus h minus f of x all over h. So first we're going to apply this in a simple case. Tell me a simple linear function. So y equals 2x plus 3. I think that's what I heard, but anyway. What is the slope of this line? 2. So everybody knows that. So now we're going to use this limit function to determine what the slope is. We already know what it is because of it's easy. What is f of x plus h? The limit is h goes to 0 of what is f of x plus h for this? Okay, well, 2 times x plus h plus 3. That is just taking x, putting x plus h into x. Minus f of x, so I can rewrite this as f of x. If y equals and f of x equals are equivalent, 2x plus 3 all over h. So now we're going to simplify this. The limit as h goes to 0, 2x plus 2h plus 3 minus 2x minus 3 all over h. Do you think it simplifies or cancels? Okay, so 2x cancels negative 2x, and then 3 minus 3, which leaves me with the limit h goes to 0 of 2h over h. What's h over h going to do? No, we can't just plug in 0, right? Because then we have 0 over 0. However, our rule of limit says we can cancel these. So what is the limit of 2? 2. Which is what we expected, right? We expected that the graph, since we know the slope of this is always 2, we expected the limit to come out to 2 all the time. So it's a good thing this works. Now we're going to apply it more generally. Let's try it with this x squared. So we had our x squared graph. We want to apply it to that. Because here we know the slope does not always stay the same. It changes depending on where we're at in the graph. So, no, I'm on that one. Let's start with f of x equals just x squared. Everybody can visualize what x squared looks like, right? Where is it increasing? 0 and going up. Where is it decreasing? So over here, do you expect a positive or negative slope? Negative here? At this point? 0. Okay, this is what we were hoping for. When we're on the right-hand side, or we have a positive number, we're going to get a positive slope. Left-hand side, we're hoping to have a negative slope. When we get to the middle, we should have a 0 slope. So again, the limit h goes to 0 of f of x plus h minus f of x all over h is our base function for slope. So now to plug it in, n equals the limit h goes to 0. F of x plus h means what? Well, squared. So we're going to have x plus h squared. You with me with that? Okay, minus f of x, which is just x squared, all over h. So we're going to do the limit, h goes to 0, x plus h squared gives us x squared plus 2xh plus h squared minus x squared all over h. Same thing get canceled. So x squared minus x squared. And notice we've got an h, an h, and an h. So cancel, cancel, and cancel with one of them. So we're at limit as h goes to 0 of 2x plus h. Now what's going to happen if we let the limit go to 0 for this? What's it going to be equal? What? 2x. Because this, if I plug in 0 now with direct substitution, this goes away. We get 2x. So n equals 2x. Now let's test our earlier guessing that we assumed. On this side, if I plug in a positive number, so if I plug in 1, 2 times 1 is 2. So if we're at the point 1, we should have a slope of 2. Positive slope makes sense. If I plug in 5, somewhere up here, 1, 2, 3, 4, 5, I have a slope of what? 10. Still positive. Now let's test it. On the negative side, if I plug in negative numbers, like negative 1, we said we should have a negative slope. 2 times negative 1 is? Negative 2. If I plug in negative 5, so it ends up, and remember, it does end up symmetrical as well, just like x squared. Now the third one, we said at 0, what should it be? 0 slope. Plug in 0 here, 2 times 0 is? 0. Is this one?
The concept is like you have an equation for an adaptive slope that will go to every point on the graph.
That will change depending on where you're on the graph, yes. So this one, this equation, so the first part of your homework is going to be asking you, find the equation of slope for the graph. So this equation right here tells us what is the slope at any point. We can choose to say x equals 20, we can say at x equals 20, the slope is 40. I think we want to do another one of these, a bit more complex. M of x equals, let's do square root of x plus x. What can you tell me about this graph? Well, what does the square root of x look like? Okay, x can't be negative, that's a good point. So, when you look at the graph, it's going to look something like that. Now, how do we apply this to this? So remember, n equals limit as h goes to 0 of f of x plus h minus f of x all over h. Now, I don't know if this one's going to come out nicely, but it could. So first, plug in our stuff. The square root of x plus h plus x plus h minus square root of x plus x all over h. See where that came from? Anybody lost? Okay. So we have the limit as h goes to 0 of square root of x plus h. And notice, this h, or this x here, is going to have so x plus h minus square root of x minus x. Again, our x's are going to cancel here. All over h. Should have a plus. So at this point we have the limit h goes to 0 square root of x plus h minus square root of x all over h. Can we let h go to 0 at this point? No. So, what method do we have for dealing with something that looks like this? Rationalization. Which part should we rationalize, do you think? So which part should we try to get rid of the square root for? Yeah, this is not going to come out as nice as I was hoping it would. I'm just looking at it as rationalizing not going to work. So we're going to say that this one, using your current techniques, you can't do it. Later, you're going to, like next section, I think you're going to have some techniques that will allow you to deal with that. So for now, we're going to skip that one. Everybody fine with that? Yeah. Okay. If we just had the square root, we would be able to do it, but that plus x made it a bit more complicated. Now, where is this applied? Where do we deal with slope? Okay, what? Okay, interest. We deal with slope a lot of with interest. What else? So one of the key things that this is used for is when you're talking about distance traveled, velocity, acceleration. Have you heard these terms? What's the formula to calculate how far you've traveled? Distance is equal to the speed times time. So velocity times time. So in other words, if you're traveling at 50 miles per hour for 3 hours, take 50 times 3, you get your distance. Now, how often do you travel at 50 miles per hour for 3 hours straight? Not too often, unfortunately. Most of the time, there's traffic or something that causes you to have to slow down or speed up. You don't stay constant, which means that your speed changes over time. We can calculate the average time. So if I told you you travel 80 miles in 2 hours, you can calculate your average velocity, right? Distance traveled divided by time. However, this does not tell us our speed at any given time. This tells us our average. So velocity average. I'm going to put v of b, meaning the velocity of b, or distance, sorry, shouldn't be v, it should be d of b minus d of a over b minus a. Okay, how far we traveled to the end minus how far we started at, divided by the distance, or the time difference. So, say we started 20 miles, for example, we started 20 miles from your house. After 3 hours, you're now 80 miles from your house. What is your average velocity? To actually calculate your instantaneous velocity, you have to use the limit process. So, velocity, what do you think it is? No. Unfortunately, it's not that easy. But you know, it's familiar. And think about it. What is the slope of this graph? Well, t is your variable. Slope would be v, velocity. So down here, our velocity is slope of the distance graph. So some of what it's going to be doing is asking you find the equation for your velocity, given that you've got an equation. Now, we haven't actually gone through and written the whole equation yet, right? We did. We got. We learned how to find the slope. Now we want to be able to do the full equation for it. Let's pull this in. And let's see, if I do y equals x squared minus 2x plus 1. What's this graph going to look like? First, what shape is it? Parabola. How is it shifted? Anybody have a guess? Or anybody know? Okay, what? Up 1? Okay, let's factor this. What is it going to factor as? X minus 1 squared. What is this? How is it shifted? To the right one. So I know it's going to look something like this. And let's see, 1, 2, 4. So I know this is my graph. And I want the tangent line, so tangent line at, let's say, 3, 4. So I want the equation of the tangent line at 3, 4. So what are the two things we need? We need our slope, and we need our y-intercept. So let's get the slope. So the limit as h goes to 0 of x plus h squared plus, or minus, I have 2x plus h plus 1 minus x squared minus 2x plus 1 all over h. You see where that came from? Anybody not see where that came from? So remember, I'm doing this part right here, f of x plus h. That's right here, f of x. And I'm going back to, I'm using the top form here because I think it's a bit easier to work with in this problem. So, again, you have to work with your algebra skills. X plus h squared is plus 2xh plus h squared minus 2x minus 2h plus 1 minus x squared plus 2x minus 1. So what stuff cancels out? Okay, so x squared is going away. So you got negative 2x and a positive 2x. Okay, 1 and negative 1. Something you should be noting, is there any pattern as to what stuff cancels out, or what stuff does not cancel out? What's common in all things that didn't cancel out? Okay, 2xh plus h squared minus 2h all over h. And that's a hint. If you have stuff that didn't cancel out, that doesn't have an h in it, something's wrong. Because if we need that h to be in each term, or else we can't cancel with the bottom. If we can't cancel with the bottom, we can't do this problem. Because now we can cancel h there, h, and one of the h's, and give us 2x plus h minus 2. And what's this going to equal? 2x minus 2. So this is our slope. Now, we want the exact number, because remember, we're now saying we want the slope at this point. So we're saying x equals 3. We're going to do 2 times 3 minus 2. So 2 times 3 is 6, minus 2 is 4. So we did all that work, we know the slope at that point is now 4. Yeah, we plugged in our x from way up here, because we said we want the point right here. So we plugged in our x value. So we can say y equals 4x plus b. How do we get b? What? Yeah, we can plug in the point. Good. We've got 3 4s, so we're going to do 4 equals 4 times 3 plus b. So 4 equals 12 plus b, b equals negative 8. So equation, y equals 4x minus 8. Yeah. Now, the question is, does this answer make sense? Is this positive? So is the slope is positive? Is the slope of this going to be positive or negative? Positive. Okay? Does it make sense that we have a negative 8 as our y-intercept, just from looking at it? Looks like it's approximately in that neighborhood. So remember, this line is not perfect, but it's just giving me, it looks like it's in that neighborhood. Negative 8 seems like it's in the right area. If I got a positive 8, I would know I did something wrong, because that would mean I'm up here somewhere. So it's a good thing to check and say, am I in the neighborhood I'm supposed to be in? So probably the most time-consuming part of this homework is that you're going to be doing this process a bunch. So this is homework, I'd say 12.3.